Okay. So, we have derived that two wave equation, this two wave equation we have derived. Now, here one thing is there that V is the particle velocity. Okay. Now, if I say volume velocity, so if you see volume velocity, if the velocity is V of let us tube with the cross sectional area is A, then what is the volume velocity? A into V is the total volume, V is the length of the tube and A is the cross sectional area. So, V is the A into V is the volume. So, if I say volume velocity is U, then U is equal to V by A, or U equal to V into A, or I can say V is equal to U by A. Now, if I put this thing on this two equations, where I can say that del square or del P by del x is equal to minus rho del V by del T. So, this will become V is equal to U by A. So, del P by del x is equal to minus rho V U by A, rho by A del U by del T. Similarly, del P by del T is equal to minus rho c square del V by del x. This will become del P by del T is equal to minus rho c square minus rho c square, or I can say del U, sorry, this is del U by del T, not del P. Del U by del T is or rho c square by A del V by del x, or I can say del U by del x is equal to minus A by rho c square del P by del T. Okay. Now, if you see this equation and this equation, these two equations if you see, this is analogous to electrical transmission line equation. So, electrical transmission line voltage V is a function of x and t, and current I is also a function of x and t transmission line. So, in that case, in electrical transmission line, minus del V by del x is equal to L into del I by del t. Similarly, minus del I by del x is equal to C into del V by del t. Okay. Now, this is analogous to, so these two equation analogous to, this is the electrical transmission line equation, lossless electrical transmission line equation. Then I can say if this equation is analogous to this equation, then I can say that P is analogous to V. So, pressure in acoustic domain is analogous to voltage in electrical domain. Similarly, U is analogous to I. Volume velocity in acoustic domain is equivalent to electrical current in electrical domain. And if I say L is equal to rho by A. So, this rho by A is called acoustical inductance, acoustical inductance. Similarly, I can say that A by rho c square is analogous to C. So, it is called acoustical capacitance. A by rho c square is acoustical capacitance and rho by A is the acoustical inductance. P is analogous to voltage, current is analogous to volume velocity. Okay. So, if you see this slide, I have written this slide, same things I have written in this slide. Okay. Now, so this I know. So, I can say that okay, if I know the equation, I can an analogous electrical transmission line I can also draw. Okay. This is same as electrical transmission line, lossless transmission line. Now, so what I want to know, what I want to do is that I want to find out the transfer function of a uniform tube, which is I can say this side is the vocal cords which acts as a piston. And so, x is equal to 0 where the force is applied in the tube, and x is equal to L where the tube radiates the sound energy in the air. Okay. Now, if I say that this one, this tube, whole tube is nothing but a this kind of situation of pressure, or you can say the pressure is applied in here, acoustical pressure is applied in here. So, I can say the particle velocity in this point, I can say, or volume velocity in this point is u 0 t, and volume velocity at this point is u x t. Pressure at this point is nothing but a P 0 t, pressure at here is P x t, and cross section of the tube is A. The area, cross sectional area of the tube is A. Okay. We consider throughout the tube A remain constant. Okay. So, now A remain constant. Now, try to find out the travelling wave solution in the tube. Okay. What is the travelling wave solution? Now, if I say that minus del u by del x is equal to A by rho c square del p by del t, or I can write down these two equations where I said this is the pressure wave equation, not this one, where it is, this will be here. So, this is the pressure wave equation, this is the pressure wave equation, and this is the velocity wave equation. Okay. Now, I have to find out the solution of this second order differential equation, and again solution of this second order differential equation give me the velocity. So, if I draw the solution of this second order differential equation, you know that second order differential is total solution is nothing but a. So, I can say that u x t is equal to u plus t minus x by c minus u plus t plus x by c. What is that? T minus x by c. So, I can say this is called forward wave, this is called backward wave. So, in the tube there is a forward wave and there is a backward wave. In the forward wave, I can say if the time axis, this is the time axis is the forward wave, then t is minus x by c. If it is the backward wave, so negative direction, t plus x by c. C is the velocity of the sound, x is the position. Now, similarly, what is p x t? P x t is nothing but a rho c by a u plus t minus x by c plus u minus t plus x by c. Okay. So, this I can say is nothing but a z t, which is called impedance of the transmission line or impedance of the acoustic tube, is nothing but a u plus t minus x by c plus u minus t plus x by c. Okay. So, where z d is equal to rho c by a. So, u plus is the forward wave, u minus is the backward travelling wave. Okay. Now, if it is that, then there is a two boundary condition in the tube. If you see, what is the boundary condition? At the glottist, at the here the glottist point where the vocal cords are vibrating, here u 0 t is nothing but a Gotthel's excitation, which is nothing but a, Gotthel's excitation is u g omega and equal to into e to the power j omega t, where this omega is the continuous frequency. So, all frequency of u. So, I can say I excited the tube with unit impulse, or I can say every frequency, and I want to find out the every frequency response at the output. Okay. That is why I said omega e j omega t, and this excitation is, if it is impulse, then that, or you can say the excitation contain all the frequencies equal amplitude, and that amplitude is modified as per the Gotthel's response, Gotthel's frequency response, that is u g omega. Okay. So, I can say the Gotthel's frequency response, which is u g omega, has to be passed through the tube, and the tube, output of the tube I have to find out, and then output by input is the tube transfer function. So, u 0 t is nothing but a u g omega e to the power j omega t. And at the ellipse, there is a radiation load is for the low frequency radiation load is completely not there. So, what will happen at the ellipse? It again it is atmospheric pressure. So, I can say P x P L T at x equal to L is equal to 0. So, if I put P L T, so what is u 0 t? So, u 0 t is u g omega e to the power j omega t is equal to u plus. So, x is equal to 0. So, I can say u plus t minus u minus, sorry, this will be minus u minus t, x equal to 0. So, x equal to 0 will be not there. So, I can say u plus t, u minus t, and if it is P L T, then P L T is equal to 0. So, 0 is P L T is equal to 0. So, I can say Z d into u plus t minus L by C plus u minus t plus L by C. Okay. So, there is a differential equation. So, since the differential equation are linear with constant coefficient, the solution must be in the form of k plus k minus represent the amplitude and the forward and backward wave. So, I can say if it is linear wave equation, forward wave u plus t, or you can say the u plus t minus x by c can be represented in the form of amplitude. This is k plus e to the power j omega t minus x by c. Differential equation, second order differential equation, and u minus I can say t plus x by c is nothing but a k minus e to the power j omega t plus x by c, exponential solution. Okay. So, this is the exponential solution. Now, if I put that value in two equation number 1 in here and equation number 2 in here. So, in 1 I can say u g omega e to the power j omega t is nothing but a k plus e to the power j omega t, because x is equal to 0 minus k minus e to the power j omega t, x equal to 0. Okay. And similarly, 0 is equal to z d into u plus k plus e to the power j omega t minus L by c plus k minus e to the power j omega t plus L by c. Okay. From here I can say e to the power j omega t into j omega t cancel. So, I can say k plus minus k minus is equal to u g omega, and here I can say z d is equal to k to this is equal to this. So, I can this is the equation number 1 and this is equation number 2. Again I can solve for k plus and k minus. I am not deducing the solution because you can do it easily. So, you can just deduce the solution and find out the k plus and k minus. So, k plus and k minus will be in the form of k plus will be equal to u g omega e to the power 2 j omega L by c divided by 1 plus e to the power 2 j omega L by c. This is the k plus, and k minus will be minus u g omega divided by 1 plus e to the power 2 j omega L by c. Okay. Once I know the k plus and k minus, then I can write down the u x t. U x t is nothing but a k plus e to the power j omega t minus x by c minus e to the k minus e to the power j omega t plus x by c. Now, I put the value of k plus is nothing but a u g omega, this value in here, and k minus I can put the value in here. Then if I put the value, then I can say u g omega e to the power 2 j omega L by C divided by 1 plus e to the power 2 j omega L by C, okay, into e to the power j omega t minus x by C minus u g. So, it is minus 1 is a plus u g omega divided by 1 plus e to the power 2 j omega L by C into e to the power j omega t plus x by C. Okay. Now, I can say that u g omega is common. So, u g omega e to the power j omega t will be same, okay, e to the power j omega t. Then I can say it is nothing but a e to the power j omega 2 L minus x divided by C, okay, minus plus e to the plus e to the power j omega x by C divided by 1 plus e to the power 2 j omega L by C. Okay. Now, if it is that, then I can solve for that, this is the u g omega. So, u g omega, if I simplify it, then u g omega this is the u x t. So, ultimately if I again simplify it, u x t will be in the form of cos omega L minus x by C divided by cos omega L by C into u g omega e to the power j omega t. Here, if I say that e to the power j theta, like that way if I do it, L minus x, if I do that, then it will come cos omega L minus x by C into cos omega L by C, if I simplify it. Similarly, I will get the p x t will be j omega z t sin omega L minus x divided by C divided by cos omega L by C into u g omega e to the power j omega t, okay, where z d is equal to rho c by a. Okay. Now, I get this to u and p. Now, what is, if you see, p is analogous to voltage, u is analogous to current. Now, if I say what is the you can say the impedance, z is nothing but a p x t divided by u x t. If I do that, p x t divided by u x t. So, it will come j z t into 10 omega L minus x by C, 10 omega L minus x by C. Okay. This divided by this. So, this divided by this. So, cos by sin by cos 10, this will come. So, this is nothing but a acoustics impedance inside the tube at any point of x. So, if x is equal to something, I can find out the acoustic impedance. Okay. So, now if the del x, if the x is variation of x is very small, then I can say that z is equal to nothing but a z is nothing but a j omega rho by c rho by a into del x omega. So, simplification of that for a small x, del x is very small, then I can do that. Okay. Now, forget that. So, this is the z. Now, if I interpreted this thing, this is particle velocity, the volume velocity, this is pressure wave, this is volume velocity and this is pressure wave. Now, if I interpreted that things, what is the envelope? Here envelope is z t pressure wave, z d sin omega L minus x by c, this is part is the envelope part, this part will be same variation e to the power j omega t, that is actually like a envelope part, and this is the envelope part in here. Now, if you say this portion is constant, if the L is constant, this portion is constant. So, one is sine, another is cos. So, if I say how the pressure wave amplitude and volume velocity amplitude is very inside the tube, then I can say only x axis here x, only I am drawing the envelope portion. So, one is sine, another is cos. So, if this cos is the volume velocity, so if the particle velocity is maximum, then pressure wave is minimum 0. So, particle velocity will vary like this. Then pressure wave or volume velocity, sorry, u is the volume velocity, pressure wave will be look like this. One is cos, another is sine. Okay. Now, if I say real part of this part, the real part of this, so if I can say, if I write u x t is equal to cos of omega L minus x by c divided by cos omega L by c into u g omega e to the power j omega t. So, e to the power j omega t is nothing but a cos omega t plus j sin omega t. Okay. So, cos part is the real part, sin part is the imaginary part. So, I can say the real part of u x t is nothing but a cos omega L minus x divided by c divided by cos omega L by c into u g omega cos omega t. Similarly, I can get the real part of the pressure wave, okay or not. So, real part of this u g omega t is this one only. Okay. Now, I come to the transfer function of the tube. So, in the tube I can say this is x equal to 0, this is x equal to L. So, if I say input is u 0 t and output is u x t volume velocity. So, I can say the V A transfer function V A omega is nothing but a u x u L t divided by u 0 t. X is L and x is 0 here. Okay. So, what is that? Now, if I see that u is equal to cos omega L minus x by c. So, at at L x is equal to L cos omega L minus at x equal to L divided by c divided by cos omega L by c into u g omega e to the power j omega t, which is nothing but a u L t. Okay. So, u L t, it is L minus L is 0. So, it is nothing but a 1 by cos omega L by c u g omega e to the power j omega t. Now, what is u 0 t? U 0 t is nothing but a u g omega e to the power j omega t, which is glottal impulse at the glottis point here. So, if I say u L t by u 0 t, so V A omega is nothing but a u L t 1 by cos omega L by c into u g omega e to the power j omega t divided by u g omega e to the power j omega t. So, this will cancel. So, it is nothing but a 1 by cos omega L by c. So, transfer function of the uniform tube where this side is closed and mouth is open, x equal to 0 and x equal to L is 1 by cos omega L by C. Okay. Now, if it is 1 by cos omega L by C, then what is the pole position? What do you mean by pole position? Pole, you know that pole. So, any transfer function, let us h omega is nothing but a consists from some p omega divided by q omega. So, there is some pole and some solution of p will give me the 0, solution of q will give me the pole. So, if you see solution of q, when q omega is equal to 0, then what is the amplitude value? Value is infinite. That means, at the pole the resonance of the system is occur. So, I get the highest energy, maximum energy, resonance will be occur at pole, every pole. So, if I have a 5 pole, I get 5 resonance frequency. So, if the fifth order q is the order is the fifth, that means I can get the fifth solution, 5 solution give me the 5 resonant frequency. How many solution I can get here? Cos theta is equal to 0 when omega L by C is equal to 2n plus 1 into pi by 2, cos pi by 2, 0. Again it will be 0 in where? Pi. Okay. So, cos pi by 2 is equal to 0. So, cos pi by 2 is equal to 0. Again it will be 0 when it is 3 pi by 2, when it is 5 pi by 2. That way if it is happened, then it will be 0. Okay. So, 1 by the V A is nothing but a 1 by cos omega L by C. Okay. So, what I described, that any transfer function can be written, any system transfer function h omega can be written as p omega divided by q omega, p omega divided by q omega. Now, if you know that solution of p omega, this polynomial will give me the what? 0, and solution of this omega will give me the pole. That is why p h omega is called the pole 0 function. So, 0 and pole. Now, what is the physical significance of pole? Suppose I said, okay, there is a pole. What do you mean by pole? Physically, what will happen? Now, if you see, what do you mean by solution of q omega? At solution point q omega will be 0. If I put it 0, then h omega value will be infinite. At solution point of p omega will be 0, the solution point of p omega, then h omega will be 0. So, I can say that if each solution point of q omega, that means in every pole the system response will be infinite. So, that means system will resonate, and every solution for p omega, which is nothing but a 0, the system response will be 0. That is why it is called pole 0. So, every pole corresponding to a resonance. In speech, those resonance are called formant. Okay? In speech, those resonance are called formant. So, I know, if I want to know the formant response or frequency response of V omega, V A omega, then I have to find out where its resonance is occur. When the resonance will be occur? When cos omega L by C is equal to 0. So, if I want to know at which frequency this cos omega L by C is equal to 0. Okay? At which frequency? So, what is omega is continuous frequency, nothing but a 2 pi f. So, I put, so omega is equal to 2 pi f. When cos theta will be 0? Cos theta will be 0 if theta is equal to pi by 2. Okay. Theta is equal to pi by 2, cos theta is equal to 0. So, I know so omega L by C should be pi by 2. Okay. Now, when okay, let us I put that 2 pi f L by C is equal to pi by 2. So, I know at theta is equal to pi by 2, cos theta is equal to 0. So, omega L by C is equal to pi by 2. If pi by 2, then cos omega L by C is equal to 0. So, resonance will be occur. So, first resonance, because cos theta can be 0, not only pi by 2, but cos theta is equal to 0 if theta is equal to pi by 2, not only pi by 2, if theta is equal to 3 pi by 2, then also it is 0. If it is 5 pi by 2, then also it is 0. So, let us minimum frequency first, that is why we call first resonance frequency is theta is equal to pi by 2. So, pi cancel, it is nothing but a 2 into f L by C is equal to half, or I can say f is equal to C by 4 L. Okay. Now, what is C? C is the velocity of sound. What is L? L is the length of the tube. Average human vocal cord length is equal to L is equal to call 17.5 centimeter. So, L is equal to 17.5 centimeter. What is C? Velocity of sound? Velocity of sound is 35 centimeter per second. So, I can say f is equal to 35000 divided by 4 into 17.5, which is equal to 500 hertz. Okay. If omega L by C is equal to 3 pi by 2, then f will becomes 1.5 kilohertz. So, it is f1 first formant, second formant. If it is third formant, then omega L by C is equal to 5 pi by 2, then it will become 2.5 kilohertz. If you see distance between the first formant and second formant is 1 kilohertz, second formant and third formant is 1 kilohertz, it is fixed because tube length is fixed. Okay. This is similar with your earlier physics theory, that if this side is closed, then the first harmonics will occur at lambda by 4. So, L is equal to lambda by 4. So, f is equal to c by lambda, which becomes c by 4 L. C is the velocity and L is the length of the tube, which is same in here also. Then it will be odd multiples of, so it is nothing, f is equal to nothing but a 2n plus 1 c by 4 lambda. Okay. So, here also same. So, f1, f2, f3 I can get. Now, can I draw the frequency response of the uniform tube where there is no loss, no nothing, any loss. So, I can say if this is my frequency axis, this is 500 hertz, this is 1.5 kilohertz, this is 2.5 kilohertz. So, at 500 hertz power is maxima. So on it will going. So, it is, I can put a arrow in here. So, it is infinite power. Okay. Infinite impulse with the impulse power at 500 hertz and bandwidth is equal to 0. It is a real pole. So, bandwidth is equal to 0. Bandwidth is equal to 0. With 0 bandwidth, infinite power resonance will occur at 500 hertz, 1.5 kilohertz, 2.5 kilohertz. If the length of the vocal tube is 17.5 centimeter and velocity of the sound is 35000 centimeter per second. Okay. So, that I know this is the frequency response for the uniform tube model without considering any kinds of loss or any the walls is rigid wall, not variable wall, means walls is rigid. So, next lecture I will discuss how this response will be affected if I consider one loss at a time. If I consider one loss, how it will be modified, second loss, how it will be modified, then ultimately we can get what should be the frequency response or what should be the response of this vocal tract tube if I get it, and what should be the transfer function. Okay? Thank you.